Hello and welcome to Orleans Virtual Meetup number 9. And today we're going to have a deployment special. We're going to hear about YAMS, which is quite a cool technology for getting stuff running in the cloud. And we're also going to hear about Service Fabric and how we could get Orleans, or perhaps not get Orleans, running on that, and how the two could interoperate. So we've got Neme and Reuben who are going to be presenting to us today. We're going to start off with Reuben, so I will stop waffling and hand over to you. This is the last time we're going to use Hangouts, I think, because we seem to have endless trouble with it. So next time I think we'll switch over to using Link, or as they call it, Skype for Business now, which might make things slightly easier, but who knows. So let's hand over to Reuben.
Hey everyone. Is my screen visible now?
Yeah, we can see your PowerPoint. We can't see the actual presentation.
You can see what, sorry?
We can see the PowerPoint with the thumbnails down the side.
Okay, great. Well, that's good. That's fine. I think that's
enough. Yeah.
Totally legible. Yeah, actually, I don't like presentation mode. Do you mind reading it like that? Is that sufficient?
That's fine. Yep, you carry on.
All right, great. All right, so I'm here to talk about deploying Orleans on top of Service Fabric. So this is something which we were doing for quite a while, particularly before YAMS came out, as Neme is going to talk about later. So I'll quickly cover what Service Fabric is, why you would want to deploy Orleans on top of Service Fabric, and demonstrate how that's done using a small little interrupt shim that I wrote quite some time ago. So in case anyone here is unfamiliar, I'm pretty sure everyone knows exactly what Service Fabric is, but for the listeners, Service Fabric is a distributed systems platform designed largely for deploying and managing microservices in pretty much any environment. Currently it only supports Windows, but I think we've been promised that Linux support is coming, and a bunch of other things are going to be supported on top of this thing. But for now, this is a service that's used inside of Microsoft to host different microservices and different large things, like, for example, DocumentDB. I use it myself when I was working on Azure Active Directory. We would host our live metrics thing called multi-dimensional metrics on there. And it was pretty good. I would say that by far the best feature that Service Fabric offers, and something which you don't see in any of the other competes today, is the state replication. So aside from just allowing you to host microservices on there and discover which microservices are hosted on there and manage upgrades and downgrades and fault tolerance and things like that, it allows you to actually plug into a replicated state machine, like I think it's a Paxos implementation, and say, okay, I've got some state and I want to replicate it reliably to a bunch of other nodes, so that in case a certain number of nodes goes down, I still retain consistency. And so it gives you strong consistency replication in that way. Now, on top of Service Fabric, the core of Service Fabric, recently they've also added a couple of other things. Now, one of them being, as you can see down the bottom there, distributed collections, which they're calling reliable services. And what that is they allow you to write application logic around a set of collections, for example, a dictionary and a queue, which are distributed and partitioned across all of your nodes. So you can write transactions that operate over dictionaries and queues and any combination of those things, and have those strongly replicate with strong consistency across your different sets of nodes. So you can compose different services out of these primitive collections. Now, also, more recently, they've added virtual actors. And these virtual actors that they've added are a little bit simpler than Orleans in that they don't offer quite as much functionality, but they're definitely inspired by Orleans because it's effectively the same model. And if you just renamed a few things, it looks almost identical to Orleans, just a lot less mature. So given that that's what Service Fabric is, you can see why you would want to use it. If you wanted to have an environment where you needed to manage upgrades and you needed to make sure that everything was running all the time, you could use Service Fabric to do that, just like you would use Mesos or another cluster manager in the Docker world. But given that Service Fabric offers virtual actors, the question becomes, well, why would you use Orleans? Now, for us, this was a pretty easy question to ask, particularly because when we first started doing this, the virtual actor offering inside of Service Fabric was much less mature than it is today. But even still, Orleans offers many more features than Service Fabric Reliable Actors. Beautifully long name. It's also far more mature. It's evolving very rapidly, and it's properly open source, as in, as demonstrated, Sergey and the team will actually work with us to implement changes and get our pull requests in, like the CodeGen heart transplant. And also our community is extraordinarily strong and warm. So for us, it was a no-brainer to use Orleans over Service Fabric. Now, the question then is, why would you use Service Fabric? And what really does it give Orleans? So if you're using Orleans, what's the point of hosting on SF? Again, for us, primarily I would say that the second dot point here, that we get high density hosting, because we would deploy a lot of little services instead of having a couple of large-scale things like you've got with Halo, and I'm sure much of the larger Orleans deployments, we rather have like a bunch of little experimental sort of apps and services that we would build. So we'd want to put web servers and Orleans and different versions of all of those things on the same physical machines, just so we can pack them all in there, because it's a lot cheaper and don't have a lot of cash to throw around. So Service Fabric allows you to pack in many little services into the same box, which is quite nice. Of course, Sergey and Gabby have mentioned about the whole noisy neighbor sort of problem. Well, in Service Fabric, the noisy neighbor problem is sort of partially solved by the fact that they offer resource management and will actively load balance your service around that cluster so that they can try and pack everything in as efficiently as possible. The other thing that Service Fabric gives you is app lifecycle management. So Orleans is fairly targeted in that it offers virtual actor hosting and virtual streams, but it doesn't manage upgrades or downgrades or anything like that. It leaves that down to the hosting platform. So by default, everyone uses Azure Cloud Services because that's what we offer in the Orleans samples. But upgrading cloud services is pretty slow. So Service Fabric gives you a similar sort of system for doing upgrades and downgrades with rollbacks and things like that. The final thing that Service Fabric gives you for Orleans is some level of independence from Azure. Now, I think that the Service Fabric team, released a build of Service Fabric that starts to allow you to deploy Service Fabric to any set of machines that you've got instead of just deploying it on their Azure clusters through the portal. So finally, this bottom point is something that can be realized by the general public. All right. Well, the deployment model in Service Fabric is that you've got a cluster containing a bunch of different applications, and those applications are made up of a bunch of different services, and those services are made up of code, config, and data packages. But that sounds like you'd have an application for whatever it is you're building, and then you'll have a whole lot of services within it. Typically, in reality, you'll find that actually you have normally one app for one service, and one service has one code package, which is just your main executable, and one config package, which is just your main configuration package. So these applications will have a manifest describing which services and versions are included. I can show you one of those. Let's have a look. Is someone saying something? I don't know if this is legible to anyone. So here I've got a calculator application, and here's the application manifest saying that we've got some configurable parameters up here. We're going to import a few services, and then we're going to say, okay, we've got one stateless service, which is called calculator service, and there are these many instances of it. That's not really that important. So Now, that calculator package itself also has a service manifest, and that service manifest says what executable we're going to run. So if everyone can read this, hopefully. Here we have the calculator service package, the service manifest for it. We say that we've got this type string. It's not really important, but hey, we run calculator service.exe, and this is code package version 1.0. And it's a pretty simple sort of model. I think sometimes it would be nice if you could define this in a cleaner fashion, but hey, this is what we've got. That's pretty fine. All right, so hopefully that makes sense. And I'll go ahead and show you. What it looks like to actually deploy an Orleans-based silo on top of Service Fabric. Now, I've done the preparation steps here already, but if you've got Service Fabric's SDK installed, you go to File, New Project, choose a Service Fabric application, give it whatever name you want, and if it's an Orleans application you're building, you'll just make it a reliable stateless service. Reliable services there are not so important. That's just the programming model that they use. Stateless means that Service Fabric itself will not hold any state for Orleans. Orleans state is managed independently of Service Fabric. So at least at the moment, maybe someday we'll change that so that we actually replicate state using Service Fabric. But for now, the shim works such that it's a stateless service. And then once that's done, you'll have an application, and you'll need to go and add the Microsoft Orleans Service Fabric silo package from NuGet, the pre-release build. So you go and install that, and you get something like this. Hopefully this is visible enough to everyone. Where we've got our calculator service, our stateless service, and later on we'll add a test client for that. But inside of our calculator service, we need to say that, hey, we're using Orleans. Now the way you do that is that the templates for Service Fabric will give you this, will generate this class for you, and initially this implementation here will be empty, and we just have to pretty much copy paste this code from the GitHub repo straight into here, and that just says, all right, when I start up and when I shut down, launch the Orleans communication listener, and that really just says start Orleans on initialization. It's really that simple actually. It goes and reads a couple of parameters from your package config. I think I sort of glimpsed at them before. You know, the kinds of parameters you're used to providing from Orleans, the silo endpoint and the proxy endpoint. And those endpoints there will be defined by Service Fabric. So Service Fabric's resource manager will allocate Orleans a proxy point and a silo point, endpoint so that they can communicate with each other. And it's actually pretty much that simple. This is all just template code here. I haven't changed any of this. And because we use programmatic config, this is just my dodgy programmatic config code here with lots of comments and whatever in it. Actually, you'll notice here as well that in the reminder service type and liveness type, I'm using Azure tables. So I'm not using Service Fabric for managing any of the cluster membership or anything else actually. So I'm not storing any state in there. I'm just using it purely as a hosting framework. So once you've done that, you will then probably want to go and create a client application. So I've got this simple calculator service, and creating the client application is very simple. All I have to do is right-click and go to NuGet, and hopefully this works. In a second. If anyone has any questions, if you could put them in the chat, that'd be great. I'll just shout them out. All right, where is he? There it is. Okay, so you just need to add the Microsoft Orleans Service Fabric client thing, which I guess I called it Microsoft. It makes it sound official, but it's not. It's made by me. That's the beauty of NuGet. Anyone can say whatever they want. And then after you've done that, after you've pulled that package in, you just need to, similarly to how you start the Azure Orleans client, you just say Orleans Fabric client.initialize, and you give it the URI which you've deployed your application to. So I said before that Service Fabric offers service discovery. Well, the service discovery works through these URLs. So I've got this app that's called Calculator App inside of Service Fabric, and then that app has a service within it called Calculator Service. And behind the hood, we just translate this string into something that we use for the deployment ID. So it just goes into the Azure tables, this string with some munging, and so that's how it does the lookup. But this just allows you to say, okay, it's the Fabric client for that app. Once that's done, you've got an application, and we can just hit start on this thing. Hitting start will deploy this calculator application to the local Service Fabric cluster, I hope. And then we'll just go inside it and punch around with the test client. So that'll take a few moments because deploying applications locally is not the fastest. It's got 5 local nodes of Service Fabric running, so it actually has to deploy Orleans 5 times on the same machine. While that's running, I'll open up a terminal, which I would have hoped had the test client, going the wrong thing. Oops. Another thing about Service Fabric is it's x64 only. You can't use 32-bit executable. Well, you can't have 32-bit only executables running in it. So in order to link to the System Fabric DLL, you strictly need to be built for x64. That thing is still cleaning out the old version of the app so it can deploy the new one. I see, Richard, you said that Nime is having trouble with his audio. I can demonstrate some YAMS if you want as well, if you'd like. I don't have anything prepared for it, but
I think that'd be great. Yeah, I think he's probably still trying to connect, but let's continue on the basis that it's just you today. So yeah, if you could do some YAMS, cool.
Cool. All right. So it looks like it's deployed now. The silo is starting up. You'll get some diagnostic traces from Service Fabric because they use ETS for everything. Is that what it's called? I can't remember the name. We'll see the normal stuff, starting a lean silo. Hopefully all goes well. Julian asked, so first it removes the previous app and then deploys a new one, not like a swap. So the reason it does that is because I haven't set it to go and do an upgrade. I think there's some way here. There is a setting there where I can tell it to do an upgrade instead. Well, here it is, preserve data on start. If I choose yes here, it'll do a rolling upgrade of the application instead of just doing a clean removal and deployment of the new one. Actually, the Service Fabric tools on this machine are a little bit old, so in the newer version, I think it might default to that. All right, is that started?
What is the RBN TDP application window?
Which one's this? Oh, that's my laptop. So I'm running Hangouts on my desktop, and I'm remote desktoping to my laptop next to me by Chrome, and running the demo from there because it's got the older build on it, and everything works in the older build. Okay, so it looks like the silo started. So if I run this test client, what it should do is connect to the silo, and then probably give me command line usage options. Hopefully this works. So far, not getting much output. probably should have slaughtered more lambs. At least the window in the background is... Oh, okay, failed to start. Storage exception. It looks like Azure Storage is not running. It's strange. Yeah, of course, that'll fail. Okay, let's start Azure Storage, and then hopefully everything should work correctly because Service Fabric is meant to be reliable and fault tolerant. So it should restart our silo, and hopefully this time, yeah, it looks like it started our silo successfully. So because storage is there, everything's there. The test client is connected to Orleans, and you can hardly read this. Can I see? But test client is returned. It's bad. It's returned 0. So our calculator just stores one value. In this case, it's stored 0. So if I type something like add 9, then hopefully it should connect into the Fabric cluster and add 9 to this value, and then we get 9. We can add it again, and we'll get 18. I hope. Of course, this is a really contrived example, but what do you really expect, I guess? Okay, so that's how simple it is deploying Service Fabric to Orleans.
Hello.
Orleans to Service Fabric.
No, it's fine. That works.
Who's that?
No, you can't hear me. It says that here, but
I can hear you.
hello?
What will we gain if we...
Sounds like you got your audio working.
Yeah.
Cool.
So I'll answer a few questions before we... Hey, near me? I can hear you. It's a little bit quiet, but I can hear you.
Hello? Can you hear me?
Yep.
Yep.
Oh, okay. Cool.
So we can do the YAMS demo.
I'm not sure
That's
how
fantastic.
to make it louder. 1 second.
Yeah, you're coming through okay.
No, yeah, we
That's
hear you
alright.
fine.
Can you hear me
So in
okay?
the-
Yeah.
Yeah. So in the meantime, Yevon asks what we gain if we implement cluster membership on top of Service Fabric instead of Azure. It's just info about dead nodes, right? Or live and dead nodes, right? So that's true. We don't gain a great deal implementing cluster membership over on top of Service Fabric instead of just using Azure. The thing you do gain is a bit of independence from Azure because you can, as long as you can deploy Service Fabric to something, then you can deploy Orleans on top of it. You don't need anything else there. So Orleans itself doesn't ever manage any storage, right? It always relies on some other platform to do that storage. One of the nice things about Service Fabric is because they do replication inside of the platform, you can say, okay, I'm just going to encapsulate every single thing into this Service Fabric cluster. So as long as I've got a set of machines with nice fast SSDs, and they can talk to each other, then I can deploy whatever kind of application I want on top. So we can deploy Orleans and do all of the grain storage and everything inside of it, and other things like that. So another example is maybe we wanted Orleans silos to have fairly complex kinds of state inside of the grain. So maybe we wanted to have a database inside of each grain so that we could do queries, but we also need to have really low latency. One of the nice things about the Service Fabric approach is if actors have an affinity to a specific partition or a specific set of nodes, we can have local disk access to a database. So you could, for example, host SQLite database locally and reliably interact with that SQLite database. So you get very low latency access to your data, and you can perform complex queries over large bits of data with very low latency and high performance. So that's one of the benefits you get by moving to a fully Service Fabric-based model with Orleans. Any other questions before we move on? Okay, maybe we should. I mean, that's Service Fabric in a nutshell. So maybe we should move on to Neme, and he can talk about YAMS.
Sounds good. Are you ready, Neme?
I am, if you can hear me.
Yes.
Awesome.
Loud and clear.
Finally. Cool. I guess I'll share my screen. Screen share.
I like the look of your bike, by the way.
Thanks.
That looks like fun.
Yeah, it is. It's that was in Worcester, actually. Can you guys see my screen now?
Yes, yeah, we can.
Awesome. So my name is Neme, and I'll be talking about YAMS, which is yet another microservice solution that was built by Microsoft Studios Big Bug. I'm going to start with a quick overview of what YAMS is, then talk a little bit about how the deployment works and some characteristics and features of YAMS, and then do a quick demo. So YAMS is a deployment and hosting solution. So all it does is just deploys your application to your VMs, and it hosts them. So it starts them, shut them down, or update them. It can be used in Azure or other cloud platforms, or on your own VMs. Applications are hosted as simple processes. So any application in YAMS is just a process in Windows. It just starts a process, and it shut it down and update it. Well, to update it, it shuts it down and then create a new process. Some features of YAMS are fast deployment. You can share infrastructure, so you can install multiple applications to the same VM, to the same cluster, and they will be installed to all the VMs in that cluster. You can use any programming language. And we also have support for upgrade domains to minimize basically downtime during updates. Okay, so to think about YAMS, you can think of YAMS as just a process running in Windows. It's installed to all the VMs in your cluster, and it keeps watching the storage, the deployment storage. So that's blob storage for now. So blob storage contains a list of applications that you want to deploy, and contains a deployment config.json file that explains what you want to deploy and where. So it contains things like the ID of the application, the version, and the cluster where the application should be deployed. When YAMS, so YAMS is running on all of those VMs, and each of these YAMS, each YAMS process is actually watching that file, and when it sees that something changed in that file, it does install new apps or install depending on what you actually modified. So one thing, YAMS need to know how to start your process. So it gets the binaries from your application folder, and it reads the app config. It expects an app config.json file that explains to YAMS how to start that process. So in here, for example, we have this Orleans host.exe. Just the name of the exe, and then we're telling YAMS to start the exe and pass in those two arguments. And basically that's it. So YAMS will see that the application, the Orleans application, has been added. It will download it from blob storage to each of those VMs, and it will start it as described in this appconfig.json file. Okay, so that's basically what the process is, but there is a little bit more during updates. So right now, what I explained, the YAMS processes don't actually talk to each other at all. They're just looking at that deployment config.json. But during updates, they need to coordinate with each other to make sure they respect the upgrade domain notion. We'll talk about this in a few slides. So the quick deployments, I mean, all it takes to deploy an application is really to download that app from blob storage to the VM and to start that app. So basically the download time plus the exe launch time, and that's application specific. YAMS doesn't do more than that. The YAMS specific time is starting a process, which is very short. You can share infrastructure. So if you say in your deployment config.json that you want to deploy your applications to the same cluster, YAMS will simply run those both applications on each VM in the cluster as Windows processes. We have support for upgrade domains. So if you have some of your VMs in upgrade domain 1 and others in 2 and 3, then YAMS makes sure that the upgrade happens in one upgrade domain at a time. So if I'm updating an application here, YAMS makes sure that the application is not being updated here or here at the same time. That's application specific. So I could be updating one application in upgrade domain 1 and another application upgrade domain 2 at the same time. That's okay. But if it's the same application, we want to make sure it upgrades on one upgrade domain at a time. One thing that is missing right now is when we're upgrading an application on upgrade domain 1, we don't actually take those VMs out of the load balancer. So it's possible that the load balancer will forward requests to here, and that will actually fail. So this is something that is supported in Azure, and we're working on adding that into YAMS. It should be fairly straightforward. But for other platforms, it depends on the load balancer you're using, basically. And also, YAMS right now doesn't know when the application is ready to receive requests. YAMS will start the application, but it doesn't really know that the application is done initializing. So that's also something else that we've been discussing with Reuben on GitHub, and we're looking at basically making those applications tell YAMS whenever they are ready to receive requests. And we're thinking about using a file or any other way.
Nemi, just sorry, while you're on this topic, there's already a startup event in Orleans host. You just need to pass the name of it, and it'll signal when it's done.
Yeah, so that's for Orleans, but yeah, that's one way. I mean, if we agree on one event that YAMS listens to, that's one way, but Orleans have that, but other applications don't right now, so we didn't really standardize the way the applications tell YAMS that they are ready to go.
Okay, got it.
So any programming language, I mean, as long as you have an exe and you put the name of that exe in your configuration file, and you tell YAMS what arguments you want to pass in, that's all what YAMS need. So let's look again at an Orleans host example. The Orleans host itself needs a silo host name, config file name, and a deployment ID. This is what the YAMS configuration file looks like. That's the one I'm using. So I'm using here the ID of the application, the version, major, minor, and the instance ID. So the instance ID, the reason I'm using the instance ID is to make it unique for each instance, because that's what the silo name, host name should be. And I'm using the prefix of the ID and version just to make sure it's unique per application. So if I have two applications of Orleans running on the same host, they don't conflict with each other. And the same for deployment ID. I also use a prefix, and then the deployment ID is unique across the whole cluster, which is also what Orleans require. So with that Orleans host.exe, which is a NuGet package, I can just start an Orleans application. You can scale your applications independently. If you have an application, let's say here app3 needs to be scaled by itself, and we want it to be running on one VM by itself, we don't want to share infrastructure with anything else, we can just put it in a different cluster, and that cluster can be scaled independently. You can just drag a slider in Azure to add VMs or remove VMs, and app 1 and 2 will not be affected at all by that. So that's completely independent. Pluggable architecture. So we did some work at making YAMS independent of a specific cloud platform. So here we have this deployment repository interface, which makes YAMS completely independent of blob storage. So you can replace the blob storage I was discussing with any storage you want. And we have an example, like in the end-to-end test, I have an example where I replace the blob storage with local file system, and it works. Otherwise, the test will fail. You can also replace the update session manager, which is this is interface where we use to collaborate between the different YAMS VMs during an update. So this is the upgrade domain in Notion. So you can replace that as well. But you can also replace basically anything else you want because we expose this DI registration as a public static. So you can, this one is called by this here. So if that's not enough flexibility for you, you can actually register the types yourself, get the container, add whatever overrides you want to add to it, and create a container, and then pass this in the constructor. So basically, you can swap any class in YAMS. So in summary, YAMS gives you fast deployment, allows you to share infrastructure, has support for upgrade domains, any programming language, scaling apps independently, and has a pluggable architecture. What's next? We're looking at joining .NET Foundation, .NET Core support. Thanks to Gutenberg, he's been helping a lot in that, and we're very close. VM skill sets template. Again, Gutenberg contributed an ARM template to our GitHub. We're looking at creating a VM skill set template and make YAMS observable. Maybe that's the wrong term here. What we mean by that is, right now when you deploy things to YAMS, you tell it what to deploy using the deployment config.json file, but it doesn't tell you back anything. It doesn't tell you I'm done deploying. It doesn't tell you what's actually deployed right now, what's being updated. All of that is not visible from the outside. So the same way we have a deployment config.json, we're thinking of having a deployment status.json that tells you what's actually happening right now at any time. So if you want to observe what's happening, you can write code to observe that and write visualization around YAMS. Demo, I can show you a quick demo of updating an Orleans application. Let me start Postman here, because I have to restart my machine. I had all of that already set up before, but because of the audio, I had to restart my machine. Okay, so I have an Orleans application here that I have a web API, and I have an Orleans grain that when you call, just says hello YAMS, like we can see here. So now I want to update this to say something else, like hello potato. And then I can just build this. And let me start the YAMS Studio. So you can do that by changing manually the deployment config.json and uploading the binaries to blob storage yourself. But we also created this sample UI that allows you to do that easier. It's like just a UI that does that for you. So in here, I have this Orleans application, version 103. I want to update it to version 104. I can just add the new version here, and I can tell it where the binaries are. So in this case, we have an Orleans application in the Orleans host, the binary release. These are my binaries. I can just say go upload. Now it's uploading the binaries to blob storage. And it will at the same time modify the deployment config.json file. Everything is still local except the binaries. Now if I want to deploy the deployment config.json file to blob storage, I just say publish to blob. I also need to update the web API. I'll explain why. It's because of the grain client that need to initialize. So I'll upgrade that one as well. And I'll pick up the web app. And just say go. I'm going to give it a minute because there's two applications being installed here. Let me start a timer. Stopwatch. Sure. So because there's two applications being installed and updated, and the reason why I'm updating the web API as well is because we need the grain client to get initialized again. I think Orleans have a way of detecting that the silo is down and then up again, but it takes a little bit longer than to actually redeploy again. By calling grain initialize again, it's faster from what I tried. So in a minute, it should say now hello potato, which proves that the application, the Orleans applications, has been installed and deployed and started again, and the old version is gone.
But in the meantime, if you connect, you would still see the old app running, right?
Yes, except if you get that load balancer hitting the VM that's being upgraded, like I said before. That's something that needs to be done to make sure that VM never gets that call, basically. So now it's ready. It should be ready. If I run this, I should get hello potato. I don't know if it was clear. Did I answer the question?
Yeah.
Okay. So yeah, basically that's we have a management API as well that allows you to deploy your binaries to your blob storage and get the binaries back. So we added a storage API basically to YAMS that this UI is using to do all that, to modify the deployment config.json and to deploy binaries. And that's all also on GitHub. Yeah, that's basically it. Do you guys have any questions?
That's very cool. Thank you very much.
No problem.
Yeah, super cool. So I think I mentioned this earlier, but since YAMS was released, we've moved most of our stuff over to YAMS. And we're finding actually that it's very good. One of the nice things about it is really easy to go and get started with. Like Neme mentioned, work currently is underway to build some ARM templates for it, so you can just do a single-click deploy from the YAMS repository and go and create your YAMS cluster up in Azure. And I guess we should probably do the same thing for AWS and Google. But I wanted to show you something really quickly if you're interested. Can everyone see my screen?
Oh, sorry. Did I?
Maybe the wrong screen, actually.
Is that my screen still? No.
Let's share this. Which screen is being shared? Screen 2, let's go this one. Can people see that? VS?
Yes.
Okay. All right, so here's an app we made at a hackathon a couple months ago. It's a simple sort of coupons app, and what it allows you to do is say, okay, I'm hungry, what cheap things are in my area, and then restaurants can say, all right, I'm going to do a deal today, 2-for-1 hamburgers or whatever it is, and just push them out there. So we built this little thing, and I can show how we use YAMS to deploy this. So if I can zoom in, how do we do that? You can see my setup. I've got a cloud service which just hosts YAMS. Zoom in. Cloud service which hosts YAMS, a very simple deployment tool, YAMS itself, and then the typical sort of all-in stuff. And yeah, I'm pretty bad about it. I put my actors inside of some common library just because it's nice for lazily developing stuff. All right, so I'll make a change, and I'll show you how YAMS allows us to do differential upload. So if I change this actor code here inside of this user grain from user to snoozer or something, I'll save that. And then I can deploy that to YAMS just by running a really simple PowerShell script that will go and build the project hopefully quickly, or maybe not.
You've got an extra little cluster in line 61, Reuben.
Yeah, what have I done? Oh, there it is. Right, I was trying to zoom in. All right, so, well, that proves that it's real. So it goes and builds a project with all my errors. We'll just hash warnings. I don't use to-dos in code. All right, and then it goes and copies them up to Azure Storage differentially. So it says sometimes that it's copying from the old version of a blob to a new version and then uploading the different files. So in our case, that's pretty much just the EXEs and their corresponding PDBs. But the nice thing for this about this is that on my little 2 megabit upload connection, here in Australia, I can deploy this entire thing, or at least copy it up to Azure in 21 seconds, which is a heck of a lot faster than I can do with other things. So one of the shortcomings with Service Fabric at the moment, at least in my view, is that if you want to use it for microservices, each of your individual applications or services has to be a self-contained package. So you can't say, all right, well, this pulls in that thing and that thing and that thing, and these things have certain common libraries shared. And those libraries might not change between versions, but if anything in that package changes, you've got to upload the entire thing. So I'll upload the PS1 script, Yevon. So that meant that for us deploying to Service Fabric, especially when we were using actual microservices, which are really fine-grained things, meant we had to upload the same stuff again and again and again, and it took an extremely long time to do. It was slower than deploying to Azure Cloud Services, which we found too slow as well. So I think it ended up taking us, I don't know, maybe 30 minutes to upload a deployment. Cloud Services might have taken about 20 minutes, and as you can see, this takes about 20 seconds. So really, really, really nice. It's a huge win there.
What's calculating the diff? Is that part of YAMS or is that part of your script?
No. So in order to do that, I've written an application a while back. Actually, I think I've got to upgrade this to the latest version of YAMS. But we've got this thing called YAMS deploy, and YAMS deploy is just a really simple tool that goes and says, all right, you've got some definition of an application, and that maps to a local folder, and then you've got a remote service, and I'm going to diff the local stuff with the remote stuff, copy that into a new folder for the new version of the application, and then update YAMS deployment config to say, all right, go and pick up the new version of that. So hopefully I can show you. I'll show you the scripts later. But the entire thing is very simple. You pretty much say, okay, I want to deploy an application from this directory with this deployment ID, which is just a service ID, and here's the connection string. And it goes and uploads the differences for you. So one nice thing as well about it is you noticed in this solution that I changed a common DLL, service common, and that's referenced by two of the YAMS services. One's the Orleans silo, and the other one is the web project down below. So both of these guys reference this common thing, but I only actually upload this change DLL once because YAMS deploy will pick up that there's the updated version of service common.dll is in the updated version of Orleans silo. And then when it's updating web, it'll go and pick it up from Orleans silo. So as long as the DLLs have the same hash, it'll go and reduce the amount of uploads that you need to do, which is quite nice. Yeah, so we're having a great time using YAMS to do our deployments.
John is asking
really,
in chat. I think it's a bit of a troll question, but so what does YAMS offer you that Azure Batch doesn't? Given that John works for Azure Batch.
I can't answer that, not knowing enough about Azure Batch. Maybe Neme can.
Sorry, what was the question?
Are you familiar with Azure Batch?
No, I'm actually not. No.
No, I've never used it either. Sorry, John.
That's a bit of a shame. One last thing, I want to mention that the Orleans Fabric silo code that I showed before, that's all on GitHub and on NuGet. So all of the instructions for that are up here. So it walks you through creating the Service Fabric service, pulling in the package, running Orleans inside of it, and then using the Orleans Fabric client to go and connect to that thing. Just real quick. All right, cool. Is there any other questions, maybe?
I think someone's asking how you get your dark CSS theme.
Okay, that's actually a legitimate question. That's a good point. Okay, so there's this cool. Do you remember when GitHub went down a couple of weeks ago?
Yeah.
I noticed that Nick Craver, one of the guys from Stack Overflow, was posting these unicorn screenshots from GitHub's 500 page, showing like a really nice black thing. I was like, oh, how do I get that? So there's this extension called Stylish on Chrome. It's really nice. It allows you to go and get new themes for other websites from user styles. So you just say, all right, go install that extension, and then get styles for it. And very cool. GitHub Dark is a good style. Similarly for Twitter and whatnot. A nice dark theme.
I was wondering how you get the cool prompt with the colors.
Oh, that. Okay, so with Windows 10, we have a new console host that I think allows it much easier console emulation. So this is actually called what is it called? I think it might be called Conemu. Conemu, yeah. So I saw someone else using this. I was like, I need that. Much nicer than what I was using.
On Linux, and that looks exactly the same. So.
Yeah, I think they use some of the some similar script, especially for this this branch status one down here. So that's provided, I'm pretty sure, by PoshGit, and this is actually just PowerShell here.
Cool.
All right. Cool stuff. Is there any other questions?
Julian, you asked one about update domains. Did we talk about that?
Yeah, I was actually asking because this is all when all the clusters are configured and so on, but I wanted to know a little bit more of how you set up the clusters before you even try to deploy to them, right? Like, what's the experience?
Okay. So I mean, from upgrade domain perspective, so when you start the YAMS process, you have this YAMS service class that you call start, and you pass in some required configurations. One of them is the upgrade domain. So you can pass in basically any ID you want. Like in Azure, what we do is we take the upgrade domain that's assigned to that VM, and we give that to YAMS because it's available through the cloud service itself. So we ask the cloud service, what's the upgrade domain for this VM, and we give that to YAMS. But if you are not in a cloud service, you need your own way of assigning an upgrade domain to each of those VMs. So you could, like, let's say you use a random number. If you use a random number, then each VM will be in a different upgrade domain. If you have a smarter way of grouping your VMs into a different upgrade domains, then you just apply that. So if you're using, let's say, AWS, and AWS has also a notion of upgrade domains, you can just take that upgrade domain from AWS and pass it down to YAMS.
Okay, great. And you mentioned VM several times. Is this like any kind of VM, like a worker role would work, or it has to be a VM like?
Any kind of VM that can start YAMS as a Windows process. That's all it takes.
Would it be right?
It doesn't even have to be a VM, right? It can be just a physical machine.
Yeah, it could be a physical machine, any machine. And the configurations that the YAMS really need are very, very minimal, like the upgrade domain and deployment ID, things like that. Very minimal. Doesn't need much.
Would the right way to think about this would be like a kind of bootstrapper, and it goes and finds the application and deploys it on there for you?
Yeah, you can think of it that way. Yeah, it is a bootstrap. Yeah, it's running on the machine, and it's monitoring your storage. You tell it what storage you want, and it's looking at that deployment config file, and if it just looks at that file and looks what you're changing there, and it does what it's sold basically.
Is there a way, I wonder, to make it completely generic, so you don't have to deploy any specific configuration with it, and then you hit its management API and say, right, this is what I want you to deploy, here's all the settings, and it goes and figures it all out.
Okay, so you're saying you wanted to not have a storage like that, or you don't want the deployment config.json, or
just curious.
Yeah. No, that's no, that's
but I just think, like, if you knew you had YAMS running on something, then it's like an empty Git repository or something. You throw something in it, and then it starts running that thing.
Sure. Yeah, like YAMS is just a library. You use it in a cloud service, or you use it outside. And one of the classes that we use right now is called like deployment watcher, I think. That's the one that keeps watching the blob storage. If you don't want to use the deployment watcher, you can basically just use the other class that does the actual deployment and just tell it to deploy. Like all the classes are public. We just made everything public. There's no internal classes that hides anything from you. So you can access those APIs and bypass the deployment watcher and just give it orders, basically. You just say deploy now.
And there's no reason why you couldn't pull the sources down from a Git repository and deploy that instead.
Pull sources down. Oh yeah, definitely. Yeah. You can create deployment storage implementations that uses Git. That's easy actually.
Yeah.
Well, of course you'd have to build it locally then as well, I mean, unless you're using .4, I guess.
If you're using Node, then you don't need to.
Oh, right, true.
But that's very interesting because then at least you can put your deployment config.json into Git. That way you can have a history of how that file changed, and you can implement like reverts and stuff using Git actually.
Yeah, Git Watcher would be very useful for that.
Mm-hmm.
Someone in chat mentioned, I think it was it Jadon? No, it was actually Richard. We should create a webhook API for it, so that we can make calls into it from build services and things like that, so that we can use it for continuous integration without having to write any custom scripts.
And you could get it to push out a notification on successful deployment, so you get an email or something.
Yeah. So that's very important component that we're looking at, like making it, tells you what's happening. Like at least a file, at least somewhere where you have the status that you can read from, if it's not a notification, but notification is even better.
Cool.
I think I should mention as well, just to recap, so YAMS and Service Fabric have a lot of similarities in the way that they manage upgrades. I didn't mention that the Service Fabric sort of rolls from upgrade domain to upgrade domain as it does the upgrade. So they both do a rolling upgrade, and they're both very similar in all of that regard. The biggest difference is that Service Fabric is a lot more heavyweight and adds state replication and a bunch of other services that YAMS is more of a library approach to. So YAMS is this nice little targeted thing that just does the deployment and execution of everything, whereas Service Fabric is much more monolithic and handles many, many more things. For example, Service Fabric will handle storing your application binaries itself. So you actually have to copy them up directly into Service Fabric. And primarily that reason that Service Fabric doesn't really give you a lot of control over the way that you manage your deployments and the way that you upload your packages is that's the primary reason why we don't do differential uploads into Service Fabric, and why we had to move to YAMS so that we could get that speed gain that we got.
Yeah, that's a very important point. Like in YAMS, we're trying to really keep it very small and specific. It's just deployment and hosting. It doesn't do more. That's why, for example, we don't have the web API yet and all of that. We're just trying to keep it simple and small and very specific.
So in future, I think it would be nice to see a really easy, obvious way to deploy Orleans on YAMS. I know that we've got examples today, but it would be good to see one-click deploy buttons for setting up Orleans on YAMS. Maybe that'll involve some project templates that have a deployment config or something like that. Or maybe we need a Visual Studio extension so you can right-click publish and publish to a YAMS cluster.
Yeah, definitely. So what I did with the YAMS Studio, I made it outside of Visual Studio just because it was easier for me, because I'm not familiar with how building UIs in Visual Studio, but the same can be done. We can have a right-click menu inside Visual Studio that does the deployment for you from there.
Yeah, especially if we stabilize around a set of maybe commandlets or I'm not sure what that enables us to do that deployment, then I think plugging that into Visual Studio should be fairly simple. Maybe we can follow the same approach that's used in Azure websites. Well, they use web deploy. Maybe that kind of thing is suitable for us too.
And
Okay.
you can use Git as well with websites and that other mechanisms.
Yeah, with Git, I think binaries is not very Git friendly.
No.
So But there is something new now in Visual in Git large file system storage or something like that. That's good for binaries, but I'm not very familiar with it yet.
No, it's all very interesting, cool stuff, and thanks both of you for taking the time. And I'm glad we got your microphone working.
Yeah, that too. That was stressful.
Excellent. Well, thanks.
Yeah.
Thanks everyone. Thanks for
Thanks a
joining.
lot.
And good to see you all. And hopefully see you again in the next meetup.
Great.
Cheers.
Cheers.
See you guys.
Bye.
See ya.